Number 6, solve the third degree polynomial equation or cubic equation. And this method we're going to use is factoring to solve this polynomial with 4 terms. Step 1, we're going to write the equation in standard form, which means the exponents are decreasing in order, and we're going to set to 0. So we have p cubed plus 2p squared minus 9p minus 18 set equal to 0. Step 2, factor the expression on the left side of the equation. Because there are 4 terms, we are going to try factoring by the grouping method. Now, if we group the first 2 terms, there is a common factor of p squared. Sometimes you have to do different groupings, like the first term with the third term, or the first term with the fourth term. But since also the last 2 terms have a common factor of 9, we're going to group the first pair and the second pair. Additionally, we have to watch out for the minus in the middle. So let's use some parentheses to start the grouping of p cubed plus 2p squared, close paren, then a minus, and then another parenthesis to group 9p and 18. But because the minus in the middle distributes, now we have to have a plus, because the minus, which is in front of a 1, which multiplies, so it's acting like a negative 1 times a positive 18. That product is a minus 18 or negative 18, that equals 0. So now we're going to factor out p squared for the first binomial times p plus 2. Now we're going to factor out positive 9 times p plus 2 equals 0. So now there's a p plus 2 as a common binomial factor that we can factor out. So parenthesis p plus 2 times p squared minus 9, close paren, equals 0. Now we can factor further because p squared minus 9 is a difference of 2 squares. It's like a squared minus b squared. And so p squared minus 9 can be factored as a product of conjugates. Let's go under step 3. So we have p plus 2, and then the product of conjugates is p plus 3 times p minus 3, and that equals 0. So this is a product that equals 0. We have 3 binomial factors equal 0, so either the factor p plus 2 is 0, or p plus 3 is 0, or p minus 3 equals 0. Then we solve each equation, so we have either p equals negative 2, or p equals negative 3, or p equals positive 3. So to check, let's check the negative 3. Let's substitute negative 3 into the original equation. So we have negative 3 cubed plus 2 times negative 3 squared minus 9 times negative 3. Does that equal 18? So negative 27 plus 2 times 9 plus 27. Does that equal 18? So the negative 27 plus 27 is 0. We have 18 equals 18, which is a true statement. So the 3 solutions are negative 2, positive 3, or negative 3, plus or minus 3. In number 7, we have a quadratic equation with a quadratic term, a linear term, and a constant. And because it's common and a good idea to eliminate the fractions, clear fractions, we're going to multiply by the least common multiple of the denominators, which is 3. We're going to multiply every term by 3. So 3 times 2/3 and 3 times 7/3, x equals 3 times 5. So dividing and canceling the 3's, we have the quadratic equation, 2x squared plus 7x equals 15. So let's get it in quadratic form, decreasing exponent order, set to 0. Now we can use trial and error. These are relatively small numbers. There's also the AC method we can review where A is the leading coefficient, C is the constant. In standard form, you have only addition, no subtraction. So the minus 15 in standard form, you would write as plus negative 15. So C is negative 15. In the AC method, when you multiply A times C, that'll be positive 2 times negative 15, which equals negative 30. I'm going to put this in a box, then an X. So AC, A times C is negative 30, and B is 7. So in these two missing numbers, we want to think of two integers whose product is negative 30 and whose sum or difference is 7. So you could figure that out mentally or write it down, have a system. So let's think of pairs of factors of 30. So this is 1 to 9 in the list. We have 1 times 30, 2 times 15, 3 times 10, and that can lead us to 7. If we have 3 times 10, but to make a negative 30, we're going to need a positive 10 and a negative 3 because the sum is positive 7, which is B. So let's continue with the AC method. We have 2x squared, and we're going to substitute for 7. We're going to replace 7 with negative 3 plus 10, because that equals 7 multiplies x minus 15 equals 0. So now we'll distribute the x, so we get 2x squared minus 3x plus 10x minus 15 equals 0. And now we have 4 terms, so we're going to continue with the grouping method. And when we group the first 2, we have a greatest common factor of x. And when we group the last 2, we have a greatest common factor of 5. So to do the grouping, we'll use parentheses, 2x squared minus 3x plus parenthesis 10x minus 15 equals 0. So we'll factor out the x times 2x minus 3, right? To check it, we would distribute the x, and then we'll factor out the 5 times 2 is 10, 5 times 3 is 15. And then we have this binomial common, 2x minus 3, so we factor out 2x minus 3 times x, and then 2x minus 3 multiplies positive 5, that equals 0. Or you can go back and just factor using trial and error, and then check it by multiplying things out. Then set each binomial equal to 0, and solve for x. So we have 2x equals 3, divided by 2 on both sides, so 3 halves, or x equals -5.